Hi there. This video is the first lesson in the biosphere section of the biosphere interactions unit of work. By the end of the lesson, I want you to explain what the biosphere is and what makes up the biosphere. So you should be able to explain all those keywords and the concepts behind what makes up the biosphere. So let's have a look at some of the information. So, what is the biosphere? It's basically made up of all living things. Life can't exist without moisture, sunlight and nutrients. When we've got that mix, there's going to be life, no matter where it is on Earth. It's the only planet in our solar system where we know life exists. The biosphere includes biotic and non-biotic, non-living and living. So soil is classified as living, as we know from the lithosphere subject. Non-biotic also includes bacteria, that type of stuff, decomposing agents. The biosphere incorporates and is the meeting place between the other three spheres. So we've got that biophysical interaction happening in the biosphere. We've got the lithosphere, which is the soil, we've got the hydrosphere, which might be rain, and then we've got the atmosphere with sunlight creating that livable atmosphere. So that's what the biosphere is. I'm going to look into more depth what makes up. So what makes up the biosphere? Well, it's the ecosystems within it. So we've got the biosphere. You can see this diagram here, and at the top we've got the biosphere. It's the sum of all the Earth's ecosystems. What's an ecosystem? It's basically a community of species and their non-living environment. So when we say non-living environment, when things die, they decompose. We have those nutrient cycles, the carbon cycle, those type of things. So we have lots of different ecosystems, one being the Great Barrier Reef, and that's what we'll be looking at next year when we look at ecosystems at risks. And naturally, some ecosystems are more fragile than others. So that's why we look at the Great Barrier Reef, because naturally it's at a lot of risks. Then what we do, we have communities. So that's all populations of species within an area. So we have different species working together. A population is a group of individual or one species. So we might be looking at how many number of wasps or bees there are in a population compared to that to moths, to butterflies, that type of thing. And then we have an organism. That's an individual of a species. So when we're looking at the biosphere is at the top, followed by the ecosystem, then a community, population, and an organism. So world's ecosystems are dynamic, so they're always changing, and we need to realise that. Some ecosystems are more resilient to change, some are not so resilient. As a result, their vulnerability increases. The more resilient an ecosystem can be, the less vulnerable it is. So as I said, there are always changing surroundings. Naturally, environments will change because the rate of change is gradual naturally. When humans are impacting ecosystems, it increases the stress, reduces resilience, and increases vulnerability. There are limits to what an ecosystem can sustain. If an ecosystem can withstand certain stresses, an ecosystem becomes at risk or extinct, and that's currently what's happening at the Great Barrier Reef. It's at risk because if we continue the way we're treating the Earth with climate change, sea level changes, then we're not going to have a Great Barrier Reef. It's going to separate into different sections, and some of the corals we're already seeing are starting to die. So that's just one little example, and I'm sure we're going to look at, and you can name some more. So if you can spend some time there, just quickly jotting down some ecosystems that you might be at risk or extinct, that would be great. There are two types of ecosystems: terrestrial, which is on the land, and then aquatic, which is in the sea, or in that area in between sea and land, where, for instance, a crab is one of those species that actually is in both. So there's a crossover, so it's not straightforward. Another example of that would be like mudflats. During high tide they're covered by sea, but during low tide they're exposed to the sun, wind, rain, etc. So there are two types of ecosystems. but it's very hard to classify them as terrestrial or aquatic, but generally that's what we do. Within a terrestrial ecosystem, there are biomes, which is a very large ecosystem made up of specific types of vegetation. The major biomes around the world are forest, and they generally have ample soil, water and heat. And when we say ample soil, soil is of a good quality, and that's why it supports lots of vegetation. We have that savanna, which is a transitional section between forest and grassland. That's when we start notably seeing fewer trees, taller grasses, that type of thing, and we start seeing the decline of the amount of water. The wet grasslands, there's a moderate shortage of soil, so we're starting to see that some of that soil is starting to turn into sand. The water and adequate heat, so just enough water, but not to the extreme where we have a desert, which is the next one, where we have extreme shortage of soil, is turning into sand. There's at least 250 millimeters of water each year of precipitation. That's what makes a desert, we classify a desert, the lack of rain, and there's plenty of heat. You will be saying, well, the world's largest desert is a cold desert, the Antarctica. You're right, exactly the same, and that's why Antarctica would come under a desert. Tundra is slightly different. Instead of a grassland, we have the insufficient heat to sustain vegetation. So we have tundra surrounding the Arctic Circle and Antarctic Circle. So parts of the year we do have the soil completely frozen, and as a result, vegetation finds it very hard to grow. There is vegetation there and also animal life, but it's very slow because of the extreme temperatures. So there we have it. We've got 5 major biomes, and that's what make up our terrestrial ecosystems, and that's what we're going to be looking at in the next couple of lessons. Okay, thanks for listening. Make sure you make your Cornell notes, and make sure you make them personal, highlight, and any questions, ask me. Thanks.